Hi there, Kenneth Udoot. I don't know. I don't know how to say that name. Okay, but anyway, so I've been working on this sequence for 3 years or 4 years, and it required quite a lot of code. I mean, not all of all these definitions here. Not all of these are directly related. A lot of them are kind of offshoots of the sequence, looking for just interesting things like, let's see. These ones are fucking weird. Convert to PFB recursive. Basically, it converts a number to this new number system, and then it converts it back, and then it flips it back, and then converts it back over and over and over and over, just to see what happens. Usually they blow up to infinity. I don't know if some of them, what's the word? Get smaller? Or what, but it seems like all of them blow up to infinity, so it's not very interesting. But the main code is down here with the stack up and the PHS. PHS is the main one. It's the prime harmonic sequence. That's what PHS stands for. That's what I've named my sequence, prime harmonic sequence. And honestly, I don't know how good of a name that is, because I know there's already the harmonic series, but this is a prime harmonic sequence. That's what I've named it, and I'm going to make the font a little bit bigger. That's the sequence. It goes on forever, but let's see. Okay. Damn it, my arm hurts holding this phone. PHS 1. And I like that it shows the prime harmonic sequence to a subsequences. So it has subsequences. So let's just see what the first subsequence is. 2, 3, 4, 6, 9. That's actually like that's not subsequence. I don't know if it's okay calling that a subsequence. Let's see what if I put a 0 in there. It might like blow up the universe, but let's see what happens. No, don't do it. Oh. Yeah, see, the subsequences are not like mathematically accurate to what I would call a subsequence. It's just for the code. But as far as the actual sequence goes, it actually puts it down precisely. And was that coming out too fast? Let me see. Yeah, I'm going to make that go a little slower. So watch, I'll make that slower. I think double it. And what else? There's I saw something there. I think the last number was printed a little bit too fast. So I'm seeing if there's any prints without the sleep. Oh, there's a return. No, there's a print sleep. I don't know why it does return stack, because it never actually... Okay, you don't know what that means, so I'm just going to play it, and let's see. Alright, hang on a second, get it. This is Nthought Canopy. This is like one of the greatest programming tools that I've ever used. There might be better ones out there, but this is my favorite. It's Python, but Nthought Canopy is this whole program. It's wonderful. Okay, so watch. This is the sequence to 10. See, there's a prime there, and everything after it is a multiple of that prime. Until you get to the next prime, everything after that is a multiple of that prime. But see, when it gets to 11, which is the next prime, it doesn't include necessarily the multiples of 7 anymore. See, there's 11. See, those are, and see, look, 11, 22, 33, 55, 77, and 121. Do you see the pattern there? Those are all prime multiples of 11. 2, 3, 5, 7, 11. So it shows you kind of what it's doing there, is that with every prime, let's go back. So 2, 3, those are the first two primes, nothing interesting there. But then 4, 6, that's another 2, 3, 2, 3. 9 is another 3. It's like 2, 2, 3, 3, 3. So 2, 2, 3, 2, 3, 3, 3. It's kind of hard to explain what it's doing there, but before I altered this sequence, it was just called the HS, which is the harmonic sequence, which is a different thing. And instead of showing these numbers, it shows the numbers in the format that shows the prime factors. So anyway, see when you get to 5, you got 5, 2, 3, 5. When you get to 7, 2, 3, 5, 7. You get to 11, 2, 3, 5, 7, 11. See, it's got an internal structure in it that's very, very beautiful. In fact, it requires an infinite number of dimensions. Every time you add another, it's a pyramid in an infinite number of dimensions, and every time you add another prime, it adds another dimension. So 2 and 3, that's 2-dimensional. Once you add 5, it becomes 3-dimensional. And so let me show you some of the stuff that this does. Hang on, I gotta find some pages here that are blank so that I can not show you all my secret things. Okay. Alright, and I'm gonna do it with a Sharpie because it's easy to see on video. Okay, so focus. Okay, so we'll write the sequence out. I've got it up there so it's easy. 2, 3, 4, 6, 9, 5, 10, 15, 25, 8. Alright, so what I'm going to do now is okay, so I'm going to make a box here. And it goes on forever, so I'll just draw some lines like that. And so the first section of this box is devoted to two things, one of them going this way and one of them going this way. And let's see, how do I usually do it? I don't think it matters, so I'm just going to do H and F. H is the highest prime, oop, I don't know why I did that. Factor, highest prime factor. F equals number of prime factors. Okay, so I'm going to continue here a little bit more. Okay, and I'll actually code this as well. This is going to be a harder task coding wise, but okay, let's worry about each one of these. And what we're going to do is for each box in this, we are going to count how many are in that subsequence. But I'm getting to something really interesting here, so don't stop watching this video. This is what I find so special about this sequence, and why I study it so much. Okay, so we will do it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. Now, 2. What's the highest prime factor? Oh, and by the way, this is the highest prime factor by the numberth prime. Okay, so 2 is the first prime. I mean, I'll just put numbers by them. 2, 3, 5, and 7 is down here, so that's 4. Okay, so the first prime is 2. So highest prime factor is the number 1. So that goes in the H section. The number of factors, there's only one factor in 2, so that goes here. And how many are in this sequence? Just 1. Because the next one goes to 2 in H. So that means that there's only 1 in that sequence, so we'll put a 1 there. This blew my mind when I first did it. Like my jaw was dropping on the floor. It was so exciting. Okay, so 3. Highest prime factor is 2. Number of prime factors, 1. But 4 has 2 prime factors, so we will actually put 4, and we're counting the number of prime factors that are multiplied. So 4 does have 2. 2 only has 1. 4 has 2 and 2. Okay, so that's different from 3. So there's only 1. That means highest is 2, number is 1. So we'll put that 1 there. Alright, now 4. Highest prime factor is 2, which is the first prime. So that goes in number 1. And then look at 6. Well, that's got a 3 in it, so that goes in the second line. Okay? Alright, now number of prime factors, which goes in F, is 2. There's 2 in 4, so since 6 is different, we section that one off as well. And we'll put a 1 there. Okay? Now, 6 is a 2 and a 3. Highest prime factor is 3. That's the second one. So it goes in this row. Number of prime factors is 2. 2 and 3. So that goes in the second row. I meant column the first time anyway. So how many of those are there? Well, is 9 the same? Yeah, it is. It has 3 as the highest prime factor and 2 prime factors. So that means that there's 2, and 5 is different because it's the next prime. So that means there's 2 in that section. So put a 2 there. Okay, so now let's move on. 5, well, we know it's different from 10 because 10 has 2 prime factors. So we section that off already. 5 goes in number 3, highest, and there's only 1, so it goes right there. And in fact, we can just realize that 7 is going to do the same thing, so we'll put a 1 there. And 11 will do the same thing, so put a 1 there. Actually, you can do 1, 1, 1, 1, dot, 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 dot. My hand's not like. Okay. Alright, so what's after that? 10? 10's a 5 and a 2. Highest prime factor is 5. That means it's in the third row. 2 prime factors, 10 and 2, or 5 and 2. So that means that there's 2, so it goes right there. But we got 15, which is also highest 5, number is 2. 25, which is highest 5, number is 2. But 8 is definitely different because that's all 2's. So we'll put another line there. That means there's 3 there. So where did that go again? Highest was 3, and the number is 2. So it's right there, and there's 3 of them, so we'll put a 3 there. Okay, I don't know if you're seeing it yet, but I'm going to keep going. 8. 8, highest prime factor is 2, so that means it's in the first row. There's 3 of them, so that means it's the third one of these. 12 is definitely different because it's got a 3 in it. So there's a line there. So that means it's only 1. It's another 1 there. And if you notice, this is doing the same thing that this row did, so we can do 1s all the way down here. Because if you think about it, the next one is going to be 16. That'll be 6, or that's 8, that's 16, that's 32, that's 64, dot, 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 dot. So that goes on forever that way, all 1s. Okay, so the next one. 12, 18, 27, alright. 12 is 2 times 2 times 3. That's 3 prime factors, so that means this row. And 3 is the highest, so that means it's this column. So how many of them are there? Well, 3 is the highest in this one. There's also 3 there. 3 is the highest in this one. There's also 3 there. Okay, 20 has a 5 in it, so we'll put a line there. So that's another 3. Are you seeing it yet? Oh my god, it blows my fucking mind. Alright. 20, that's a 5, a 2, and a 2. So it's 3, so it's 3. And it's here. Okay, so let's count how many of those there are. Anything that gets past 5, that's when you stop doing it. So it gets past 5 there. So it's got all of these. 1, 2, 3, 4, 5, 6. Oh my god. Are you seeing it? Okay. I'm not even going to continue this because I already know what they all are. Do you see it? It's a fucking Pascal's triangle. 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Seriously, I have checked this. It goes infinitely. It's the Pascal's triangle. And I made this thing out of a procedural thing that I made up, that it's so hard to understand. I mean, look at how complicated the code is. It really isn't that complicated, but like compared to, I don't know, most sequences, you can just make an equation that does it. This one, it needs this procedure to print the sequence out. Okay, so how does it work? How does it work? Okay. So so you start with 2, that's the first prime, then you go to 3, second prime. Now what do? Well, you're going to say, all right, my highest possible number of factors is equal to the number of primes I've used, which is 2. All right. When you're here after 2, there's nothing else you can do because you only have a 2 to work with. So you only work with the primes that have already been placed, and you only work with the number of primes that have been placed equivalent to the number of factors that you are allowed to now place. So you get to 3, and what do? Well, you have a 2, and you have a 3, and you have 2 factors. So that means the next thing you can do is combine them, but you can only use 2 factors. And you have to go to the lowest possible one, which is going to be a 4, because it's 2 times 2. 2 factors. Highest available one is 3, but you're not at 3 yet. And then 6, 9, because then you... So now I'm going to convert it all to a different system. 1, 10, 2, 11, 20. So this is what is underneath the hood of this thing. Okay, so let's see. So you've got 1, 0, 1, 2, 1, 1, 0, 2. And then what? Well, now you've used up the number of primes that you have, which is 2. You can't go to 3 because you don't have that many primes. The primes give you the number of factors that you can use. So you have to open up the doorway to the next prime. So that's 0, 0, 1. That's a 5. So this is 2, 3, 4, 6, 9, 5. And then you got to fill these up. Which is a little bit hard to describe. But now you've got to 2. The next thing you have 3 factors that you can work with because you've gotten to 3 primes. So now you go to 3. And then it does this thing. See, when it goes 2, 11, 20, that's going from the lowest possible amount of the lowest possible number to the highest possible number within that subsequence. So now you do the same thing with a 3. It goes 3, 21, 12, 03. So see how that works? You take 1 from here and move it to the right. Then you take 1 more from there, move it to the right. Then you take the last one from there, move it to the right. Now you've got one more thing. So you're going to take 1 from there, move it to the right, and the rest of them are going to fall down to the left. So you're going to get 2, 0, 1. and then 1, 1, 1, and then you take the furthest left, move it to the right. 0, 2, 1. Yes, I figured this out. This gives you the fucking Pascal's triangle just by moving these one to the right and then dropping them down. It's like so random how it works, but watch. You take one from there, move the rest down. 1, 0, 2, 0, 1, 2, 0, 0, 3. Now you've run out of the third line. You have 3 in the third line. You have to move on to the fourth line. Bring in the next prime. That's 7. Okay. Then you do these ones again. I'm so excited about this because somebody is actually like maybe kind of into math. I'm not really sure. What's next? Oh, then you got to add one more. But watch, you do it by the same way. You add one there and then you drop it all down. So it's going to be 2, 0, 0, 1. 1, 1, 0, 1, 0, 2, 0, 1. Then you take 1 there, drop it down. 1, 0, 1, 1. 0, 1, 1, 1. 2 there, so 0, 0, 2, 1. 1 there, drop it down. 1, 0, 0, 2. 0, 0, 1, 0, 2. 0, 0, 1, 2. 0, 0, 0, 3. Now you're finally to 4. That is 16. So the 3 here, that's 8. That's 4. So 2, 4, 8, 16. And then 5 would be 32 because these ones are just powers of 2. Okay, so 4 goes to 31. 22, 13, 04. Okay, and you just keep going. This is all just taking one, moving it to the right, and then dropping the rest down. That's how this works. That's how I figured out this sequence. And then later, I figured this out. And that is what is so fucking cool, that I discovered this out of this just idea of taking a number, the factors. These are the factors of a number, by the way. You take the factors of a number, you move one over, you drop the rest down, and once you run to the final end, you add another prime, and then you do it all again. And out of that, which was just a random fun little thing I was doing, I found Pascal's triangle. Isn't that cool? I think that's so cool. And now you're telling me that it's not in the sequence database. That's whoa. What? Maybe I just discovered something amazing. Okay, I'm just gonna do it again, but I'm gonna make it fast so we can see it go real fast. So make this 0.0 or 0.1. So just to end the video, because I think I've run out of things to say. I haven't studied it beyond that, really. So I'll just do 50. It's going to go forever. Maybe not. Maybe it's really fast. It's kind of interesting to look at these dips and these bumps. It's like how many digits it is in base 10. It's an interesting thing to think about. Wonder what happens if I make the font really small. I'm gonna turn that up. Actually, I'm gonna turn up that that sleep number, the sleep number bed. Okay, I'm gonna turn that sleep number up. Fuck, that's tiny. Okay, I'm gonna put 0.001. I don't even know if it goes that short, but let's see. The sleep number is the amount of delay that in between each cycle. Oh, I think that says... Oh, no, it worked. Okay, so let's do PHS 100. This is going to go forever. It pumps it out really fast. Ooh, that's nice. They're getting nice and big. Oh, did you see that? It went back to a prime. That's so cool. Oh my god. Oh, no. That's probably some kind of power of 2 or something. Gonna get back to a prime. It's gonna get to a prime. Come on. Oh, I think that might have been it. Maybe. Well, isn't that fascinating how it does that? I wonder what it would look like in binary. It'd probably be even longer. That might be more mathematically relevant. Wow, I might have actually stumbled onto something like with legit mathematical value here. Look at these numbers. These are pretty big numbers. Oh, that must have been a prime right there. A pretty big prime. Look at these numbers. They're huge. It's hypnotic a little bit. Actually, it's not quite as hypnotic as the harmonic sequence is. That one is that's this here. This is the harmonic sequence. It's a lot more fun to watch because you get to see these diagonal lines like this one. Get to see these diagonal lines. But this looks like a city or something. It's got like some kind of structure to it. I told you it's a pyramid in an infinite number of dimensions. It's you see those edges? It's like these triangles. It's all pointing back to that 2 at the start. These see they come out like that. It goes out like that. It's triangles within triangles within triangles. They're all pointing back to that 2. It's a fractal. It's definitely a fractal. I think it's like it's connected with mathematics in this really special way. I'm not really sure. Ooh, this must have been another prime or something. Yeah, definitely the primes are the really short numbers. And then I want to map this onto a graph. I haven't done that yet. I'm not good enough at Python to know exactly how to do that yet. But I will do that as soon as I learn how. See, this is just printing them. It's not actually saving these numbers. They're just saved in RAM, I guess. Yeah, I guess that's it. I don't have much else to say. So, pretty cool.